So we're going to cover chapter 11, section 7. Today we're going to cover surface area and volumes of cones. But before we can learn those formulas, let's learn about the different parts of the cone. So just like before with the pyramid, we had a slant height and a height, and we're going to have the same thing with the cone. The height is going to be from the center of that circle up to the vertex, and then the slant height goes down the side of the cone. And we're going to have a radius that we're going to need to use for all of our formulas. So the base shape, whenever it's a cone, is always a circle. And then the lateral surfaces is like the sides of that cone. So here is the first formula. And the first formula is for the lateral area of the cone. And that's, you're going to memorize to be pi RL. The way that they came up with this formula is by using the area of the sector formula, because again, it's not a full circle, that lateral area of the cone. So that's how they developed it. But again, just memorize that the lateral area formula is pi RL, where L is the slant height of the cone. Then for the surface area or total area, that's going to be the area of the base, which is a circle, pi r squared, times or plus the lateral area. So again, just like before, it's capital B, area of the base, pi r squared, plus your lateral area, which is pi RL. Then we're going to learn the volume of a cone, which is just like a pyramid. It's going to be 1/3 area of the base times the height. But when it's a cone, it's always a circle for that capital B. So you'll find the area of the circle base, times it by the height, and then either multiply it by 1/3 or divide by 3. So this is very similar to the pyramids. Because again, the formula for volume of a pyramid is 1/3 BH. But what changes with the pyramid is that shape of that base. What's nice about the cone, it's always a circle. And if you think about it, it's very similar to the cylinder. Because remember, the volume of the cylinder, again, it's got a circle here on the bottom and the top. The volume of the cylinder is BH, no 1/3. And again, that base is a circle. So the only difference between the cylinder and the cone is it's missing the 1/3, because we haven't cut off part of it. So let's go ahead and try some examples using the formulas you just learned. So the first one, it wants me to find the area of the base. That's what the capital B represents. And again, your base shape is a circle. So we're going to do pi r squared. That's the formula for area of a circle, which is our base. My radius in this picture is the 5. The 8 in the picture is the slant height. So pi times 5 squared. And left in terms of pi, it's 25 pi meters squared. However, using your calculator and rounding it to the hundreds place, it's going to be 78.54 meters squared. And this will give you the area of the base. For the lateral area, so that's like the sides of this cone, that formula that you're memorizing is pi times radius times the slant height. Again, my radius is 5. My slant height is 8. Left in terms of pi, it's 40 pi meters squared. Using my calculator, multiplying 40 times pi, I get 125.66 meters squared. Now what's nice, since I'm doing this step by step, to find the surface area or the total area, remember that formula is just area of the base plus the lateral area. And I already calculated area of the base in part A and the lateral area in part B. So the area of my base, if I hadn't done this ahead of time, it's going to be pi r squared plus pi rl, but I've already done it, and I know that the area of the base was 25 pi. The lateral area is 40 pi. Add those together, and I get 60 pi meters squared. So that would be the surface area or the total area left in terms of pi. Using my pi button, 65 times pi gives me 204.20 meters squared. So again, this is total area or surface area. And then the last part is the volume. Now, remember for volume though, the formula is going to be 1/3 capital B times H. And again, remember your capital B, we've already calculated it. 1/3 pi r squared height. What we don't know yet is the height. But if you look over at our figure, we can find the height of this cone by doing Pythagorean theorem. So we have the radius and the slant height. So in order to find the height, I'm going to do h squared plus 5 squared equals 8 squared. H squared plus 25 equals 64. Subtract the 25. H squared equals 39. Now I need to square root it. I would want to leave this in simplest radical form. I can't break down the square root of 39. There aren't any perfect squares, so I'll leave it like that. So when I go to do this, for the volume though, I'm just going to use my calculator and I'm going to figure out what the square root of 39 is. So I've already done the capital B here. I did that in part A. So it's 1/3 times 25 pi times the height, which is the square root of 39. I'm going to go ahead and multiply all of this and round it to the hundreds place. So 163.49, and this time it's meters cubed. On the quiz, I may not ask you to find like 4 different things. I may just say, find the volume and find the surface area. And then you'd have to go back and then find the base area and the lateral area and then put it into the surface area formula. Let's try example 2. Exactly the same thing. It's asking for the same 4 pieces of information. So for example 2, the only difference here is they didn't give me the radius, they gave me a diameter. So the 24 is the diameter. I need to turn it into a radius by dividing it by 2. So the radius is 12. I could go ahead and calculate my height while I'm right here. So again, we've got the radius, which is 12. We've got the slant height, which is the 13. So now to find the height, I'm going to use the Pythagorean theorem. So again, I'm going to do h squared plus 12 squared equals 13 squared. This is actually a triple if you've memorized your triples. If not, do the Pythagorean theorem. I'm going to square the 12 and the 13. I'm going to subtract the 144. H squared equals 25. Square root it. And the height of this cone is 5. Now I have the value of all the variables that I need to answer the 4 questions. So for the base, again, the base of a cone is always a circle. So pi r squared. Again, my radius is 12. So pi times 12 squared. Left in terms of pi, 144 pi meters squared. Using the pi button, pi times 144 gives me 452.39 meters squared. For the lateral area, we're using the formula pi times radius times the slant height. And again, I already have the value of R and L, so all I have to do is plug it in. R is 12, slant height is 13. 12 times 13 is 156 pi meters squared. If I'm using my pi button, I get 490.09 meters squared. For part C, for the surface area, again, remember it might also be referred to as total area. B times, or B plus the lateral area. And again, the area of the base was pi r squared. Lateral area is pi rl. But we've already calculated the base and the lateral area. So I'm just going to plug it in. 144 pi plus 156 pi. Add these two together. 300 pi meters squared is left in terms of pi. If I use my pi button, 942.48 meters squared. And lastly, the volume. Again, formula for volume, 1/3 BH. And again, we've already calculated the B up in part A. So volume is equal to 1/3. 144 is the area of the base. And the height we found with the Pythagorean theorem. And we found out that the height was 5. I'm going to go ahead and this one, it'll divide evenly. So 240 pi meters cubed for volume. And then using the pi button, 753.98 meters cubed. Again, if you want to memorize the whole thing, it's 1/3 pi r squared height. That's what the capital B represents, is the pi r squared. We've already done this with the pyramids and the prisms, using the scale factor to find a missing area or a missing volume. So again, what I need to do is first find the scale factor. And again, just stay consistent in your problem. You're going to either do it as cone A's radius over cone B's radius or B over A. It doesn't really matter. So I'm going to find the scale factor or my K value. So if I end up doing cone A over cone B, when I set up the proportion with the volumes, I need to stay consistent. So I'm going to be doing cone A's radius over cone B's radius to get my K value. So I'm going to do 3/9, reduce that to 1/3. So my K value is 1/3. But for volume, we need to take that K and we need to cube it. So I'm going to raise 1/3 to the third power, and K cubed is 1/27. I'm now going to use that K cubed to find the missing volume. So I'm going to be setting it up as volume of A over volume of B. Now, if you would have found your K by doing B over A, then you would have set up the volumes the same way. And I'm going to set this equal to the K cubed. So they gave me the volume of A is 15 pi. I'm going to set X equal to the volume of B because I don't know that. That's what I'm looking for. And my K cubed was the 1/27. I now have a proportion. I'm going to cross multiply to find X, which is the volume of B. So 15 pi times 27 and 1 times X, and I get 405 pi is going to be the volume of cone B. and that's left in terms of pi, and this would be feet cubed. However, using my calculator's pi button, the answer would be 1,272.35 feet cubed. Most of the homework questions are going to expect you to use the pi button. One last example, and we're done. We're going to find the volume of a composite figure. So we're going to be finding the volume of two separate shapes and then adding them together. And then the last example wants us to find the volume of this composite solid. This composite solid is made up of a cylinder and a cone. So to find the volume of this particular composite, I am going to find the volume of the cylinder, which is on the bottom, and add it to the volume of the cone, which is on the top. So remember, for volume of a cylinder, it's BH. For volume of a cone, it's the 1/3 BH. Now, notice I've got two different H's here, though. I've got the height of the cone and the height of the cylinder. So what I'm going to do here, again, both capital B's here are circles. So the formula for volume of the cylinder is going to be pi times radius squared, and I'm going to call this height of the cylinder my H1, just so I know the difference between the two H's. And then for the cone, same thing, it's a circle base, and I'm going to call this height number 2, and that's the 5 up here. The radius is this 3, and it's the same for both. So let's plug in our numbers. So pi times 3 squared times 10 plus 1/3 pi 3 squared times 5. So I'm going to go ahead, pi times 9 times 10, 1/3 pi 9, 5. And again, I'll multiply 9 and 10. I get 90 pi. Multiply 1/3, 9 and 5, and I get 15 pi. I'm going to add those together. 105 pi centimeters cubed would be the volume left in terms of pi. Using my calculator's pi button, 329.87 centimeters cubed would be the volume of this composite solid. And that's it for the notes on 11.7.